It takes you months to get started with those solutions. This was also one of my goals. I want anybody to be able to start in 5 minutes. And with our solution, there's none of that. You start with your images, with the stack and applications that you love and already know. Your engineers are all tooled up on it. You have all your DevOps scripts and languages and all the things lined up. Your CI/CD pipeline understands everything that's going on. Your scanners understand everything. We start with that image. We patch it to 0. You have your image, but better in 5 minutes. And so, we checked all the boxes on our wish list of how we could make this good for John Amaral, 4 years ago at Cisco. And here we are doing that. Now, as soon as we see your image, if any new vulnerabilities come up, because we know your image, we go patch it. We find as soon as a new vuln comes, our software factory and our AI agents kick off a process where they go figure out what to do automatically. So you've been in security a long time. Patching SLAs, right, are pretty strict. Depends on the regime, but with FedRAMP, it's 7 days for a critical. Um, you know, what do you do when no patch exists? Well, you're kind of you got to do a POAM. You're going to be on the hook to for Kanban, right,
Right.
etc. Our autonomous software factory has always got your back. So it's it's like you take the engineers out to lunch and try to get them to pay attention to the security stuff you want done. Our system doesn't need lunch. It just needs electricity, and it wants to solve all your patches for you. You don't even have to take it out to lunch. So that's how it works. Questions, comments, thoughts. I'd love to hear your take on all that.
I mean, I think it's really, really fascinating. You're kind of teasing me here. Now I want to dive into the tool.
Let's go. Let's go. I'm going to do a screen share. Good thing we tested this early. I know it's going to work, so that's cool. I'm just going to press go on the screen share and
Yeah, when you said screen share earlier, I was like, we need to test that because I've never done that before on
yeah.
this.
All right, we're forging new ground on the on this podcast. I'm going to do this guy right here. Nope, that's not the one. That one. There we go. Share. Hopefully it works twice.
There we
Are you
go.
seeing my screen?
Yeah.
Cool. And hopefully it's zoomed in enough so the audience can take a look. All right. So I'll get in and certainly stop me, Joe. And I don't have this is covering your face now, so I wish it wasn't that way, but it is. But just yell at me to stop so you can ask questions as we go. So basically, there's a bunch of parts to the solution. One is we've got this dashboard that's trying to give you a high level view of all the good work that this solution does for you. You can see this is just a test account. I test all kinds of containers in here, but in the profile of containers I've done, you see that I've had a 73% vulnerability reduction across all issues. It saved 77 days worth of work. 270 vulnerabilities are remediated. I sometimes throw stuff at this that are really hard tests for it, but in general, it works very well at remediating, and you have an easy way to see what's going on. The system really, kind of runs from this point. This is the remediation tab. This is where you get started. It allows you to connect a bunch of registries. So we have pretty much every registry under the sun, as I said earlier. First thing you do is you tie us to your registry if you want us to work on your private images. We also work on public images. You can start by picking something on Docker Hub. That's what I'll do for this. But when you connect this up, you just put a registry token here, a security token. And then once we have read-write access to that registry, when we remediate an image, we just push an image right back to that same registry, but tagged with root IO under it. For public images, this is a super simple way to test, and anyone can sign up and use this platform. There's no gating on it. You can go check it out yourself. You can do all the things I'm showing you here without any intervention from our company. We don't ask you to call us for a demo. You just sign up, try it, and it's easy. I'm going to pick Python. I talked about that earlier. You just select one of these images, or you can pick from whatever tag you want up on Docker Hub. Today we support, as I mentioned, Debian, Ubuntu, and Alpine images on AMD 64. Pretty wide support setup. And then you just click the remediate button. It's going to bring up a modal dialog here that kind of tells you what's happening. So we first pull the image, we scan it. We have the Trivy scanner under the hood. We also create an SBOM of that image. Once we do that, we go into this evaluation mode. We look at the container composition, the packages, the vulnerabilities, and we make that patching plan I talked about, where we do patch selection from the upgrade list, try to select patches that have a low semantic version difference from the package that's in your image. But our goal here is to kind of like preserve the 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 packages you have from a major and minor version perspective and bring, I'll call it, very small change upgrades to it, just targeting those vulnerabilities. Now, the goal of this is not to upgrade functionality. It's literally to patch away the vulnerability. So we're very targeted in that. And of course, we also select from those root patches that we've generated that we can use with the same mindset. It's like bringing these patches to bear to literally target elimination of vulnerabilities so that your risk profile in the container and your ability to meet compliance for vulnerability counts and SLAs is made easy.
Yeah, it's it's fascinating because I'm wondering how long it took you to like train the AI model to build up to the point where it kind of knew what to do, right? Where it was becoming more effective for your use cases. Can you talk a little bit about that potentially?
We're pushing to roots registry. That's what it should do for a public image. So now it's
Hmm.
scanning. So let me take off from here, and then I'll answer your question in a minute.
Okay.
So it's scanning the image now. It pushed it to internal registry that we have, ECR registry, where we create a temporary location for it. This is the public image, so didn't have your registry to push back to. We scan it again after we do all the patching, and then we we then present the findings and a link for you to be able to go and retrieve the image. So part of this is we generate VEX and SBOMs for everything we do. So the VEX statements actually have a very detailed record of everything we patched, all the new packages we applied, and you can use that VEX file to inform your scanners of these package changes, because natively most scanners don't understand these package changes because we've generated them. So we make it really easy and transparent for users of our system to be able to do that. And voila, here you go. We've got an image that had one high and critical, and I'll show you more about this in a second, down to 0 highs and criticals. Now, that image was a curated image that already had like a bit of it risk surface reduced. And then here is a pull command for Docker that you can go and grab that image yourself, drill in and get the full report. And further, it just didn't get rid of the high and critical. It got rid of all the mediums. So this container has 0 highs, criticals, and mediums. This is a very typical result for the image, for these operating system images that I've shared. It could be Python, Node, whatever, PHP, but we have very good success across a whole bunch of images. I'll show you the kinds of images we operate on, and because we have a big list of those that we test on and offer as, I'll call it, convenience images for people, but we don't sell images. We sell this service. You can run this on your images. If you have a Python version that's on Debian that you use for your base or Node or you name it, you don't have to rebase. You just run our tool and you get a new image that has much less vulnerabilities. Behind the scenes here, we added 18 of these root patches, these custom patches that we developed using our agentic AI system and our really fabulous research team. And something to note, I mentioned that these semantic versions are very close. So, and in fact, this libcap2 vulnerability has no patch in Debian. That's why it's a root patch. And we actually provided a patch for the exact library you had with our root extension, and we probably only changed a few files and like in a kind of a small number of lines of code, probably less than 100 lines of code is typical that we'd have to change. It's very surgical.